Imagine you're standing in Yellowstone, watching a hot spring breathe steam into the cold air, and the ground under your shoes is part of a volcano bigger than the park map can even show. Now imagine the sky goes dark, not from night, but from ash. The question is simple and horrible. Could you survive if Yellowstone had the big one? Most people hear Yellowstone Supervolcano and picture North America getting erased in one giant movie explosion. Lava racing across states, cities instantly vaporized, a countdown clock under Old Faithful. And honestly, that reaction makes sense because Yellowstone really has produced eruptions so huge they left ash across enormous parts of the continent. But here's the uncomfortable twist. For most people, survival wouldn't be about outrunning lava. Lava is almost the wrong monster. The real question is whether you can survive hot ground-hugging ash near the park, powdered glass falling from the sky farther away, and then the quiet, boring collapse of normal life after that. Breathing, drinking, driving, power, food. Those are the killers that don't look cinematic. So let's walk it out like you're actually in the scenario. First, what would Yellowstone be doing physically? Then, who is basically out of luck right away? Then, where the survival zone begins. And finally, the part people usually miss. The eruption might end before the hardest survival problem even starts. First, Yellowstone isn't a giant cone volcano waiting to pop like a champagne cork. It's a caldera. That basically means a huge volcanic basin formed when past eruptions emptied so much magma from underground that the surface collapsed downward. You're not looking for one neat mountain, you're standing on a scar. Also, and this matters, Yellowstone isn't overdue in any meaningful clockwork sense. Volcanoes don't erupt because a timer dings. Most of the magma under Yellowstone is more like a hot crystal slush than a giant underground lake of fully liquid lava. That's one reason scientists don't treat the park like it's about to sneeze tomorrow. The most likely future volcanic event at Yellowstone isn't a continent-scale supereruption. It would probably be a much smaller lava flow, or even more likely, a hydrothermal explosion where overheated water flashes into steam and blasts out rock. Yellowstone has done that before. Some of its explosion craters weren't made by magma reaching the surface at all. They were basically pressure cooker failures. But the title isn't asking what is likely. It's asking if you survive the worst plausible version. So let's assume Yellowstone somehow builds up enough eruptible magma and goes huge. If you're in the park or close to the caldera when that starts, this becomes brutally simple. You're probably not surviving. Not because lava is chasing your car. The main near-field danger is a pyroclastic density current, which is a hot, fast, ground-hugging avalanche of ash, rock, and volcanic gas. Think of a landslide made of furnace air and shattered stone. It can move across the landscape faster than highway traffic, pour through valleys, climb some ridges, and leave behind sheets of volcanic material that used to be part of a boiling cloud. This is where movies actually underplay the weirdness. You might imagine one blast from one hole, but giant caldera eruptions can open long cracks or multiple vents. They can pulse. The vent area can shift. The land can sag as material leaves the magma chamber. So the danger zone isn't a neat circle where one side is safe and the other side isn't. It's a violent, changing volcanic construction site the size of a region. A deep bunker sounds comforting until you remember that heat, ash, gas, and burial all have to be solved at once. A normal basement isn't a spaceship. If you're close enough for pyroclastic flows, survival stops being a plan and becomes a miracle. But now, here's the first real twist. Most people in the United States wouldn't be in that instant death zone. They'd be in the ash zone. And ash is where Yellowstone gets less like a monster movie and more like a disaster that attacks every machine and habit you rely on. Volcanic ash isn't fireplace ash. It's not soft dust from burned paper. It's tiny broken pieces of glass and rock. Under a microscope, a lot of it looks jagged like smashed bottles ground into powder. So, if you're downwind, the sky may start dropping something that scratches eyes, clogs lungs, ruins engines, gums up water systems, and turns roads into gray paste when it gets wet. The exact ash map would depend on wind. That's a huge detail. Two towns the same distance from Yellowstone could have very different experiences depending on where the upper-level winds are blowing during the eruption. The worst ash usually doesn't fall evenly like a blanket placed over the country. It makes lobes, streaks, and thick zones, like smoke from a huge fire stretched by weather. If you're a few hundred miles downwind, you might get enough ash to make daylight feel wrong, collapse weaker roofs, and make driving nearly impossible. A few inches of ash sounds manageable until rain hits it. Wet ash gets heavy fast, and it doesn't politely drain away like snow. It packs, sticks, and loads roofs. Flat roofs are especially vulnerable. A steep roof sheds more. That tiny architectural detail could become a survival detail. And here's a detail people rarely mention. You shouldn't just blast ash away with water like it's driveway dirt. That can make it heavier, turn it into sludge, clog drains, and overload systems that are already failing. Dry sweeping can throw glassy particles back into the air. Cleanup becomes this annoying balance of removing weight without creating a breathing hazard. So could you survive heavy ashfall? Yes, if you're not too close, you're indoors, your roof holds, and you treat ash like a toxic weather event rather than snow. You'd seal drafts as best you can. Keep ash out of drinking water. Wear goggles and a proper mask if you have to go outside. Keep pets in. Avoid driving unless it's life or death, because ash destroys visibility and can chew through engines and filters. But hold on, because the ash itself is only the loud first problem. The quieter second problem is that ash doesn't need to bury a city to break a city. A thin layer can shut airports, and not just because pilots can't see. Volcanic ash can melt inside jet engines, then reharden on turbine parts as glassy gunk. That's why ash clouds are treated so seriously in aviation. It can also contaminate electrical equipment. When ash gets wet, it can conduct electricity across insulators, causing flashovers. That means power systems can fail from a layer that looks almost insultingly small. Water gets messy too. Open reservoirs can collect ash. Treatment plants can get overloaded with sediment. Pumps and filters can wear down. If you rely on rainwater collection, ash can turn your roof from a water catcher into a contamination surface. Suddenly the question isn't, did my town get buried? It's, can the town still run? This is the part where distance becomes weird. Someone much farther away might be physically safe from heat and heavy ash, but still trapped in a web of broken logistics. No flights, fewer deliveries, power interruptions, roads that are technically open but awful, hospitals dealing with breathing problems and supply shortages, farms covered in abrasive dust, animals grazing on contaminated forage. The volcano doesn't have to reach you directly if it reaches the systems feeding you. So let's put you into a realistic survival tier. If you're inside Yellowstone or very near the caldera during a true supereruption, the honest answer is probably no. If you're in nearby parts of Wyoming, Montana, or Idaho under the heavy ash path, survival is possible but ugly, and your exact building matters. Strong roof, stored water, sealed indoor air, food, radio, eye protection, and staying put could matter more than a full gas tank. If you're in a city farther away, say hundreds or even over 1,000 miles downwind, you probably survived the eruption itself. But your life could become deeply disrupted. Ash can make normal errands dangerous. It can turn a grocery run into a dust storm. It can make a generator fail if the intake isn't protected. It can make a hospital's clean air system suddenly very important. And if you're on the other side of the continent, the answer might be, yes, you survived the volcano, but now you're living through the aftershocks of a national infrastructure crisis. That sounds like the end of the answer. It isn't. Because the biggest survival question may not be the first week. It may be the next growing season. A super eruption doesn't just throw ash. It can also inject sulfur gases high into the atmosphere. Up there, those gases can form tiny reflective particles called aerosols. Think of them as a very thin, high-altitude haze that bounces some sunlight back into space. Less sunlight reaching the ground can cool climate for a while. This isn't the same as smoke sitting low in the air, and it's not the same as carbon dioxide warming the planet. It's a short-term sunlight problem. Big eruptions in history have cooled global temperatures for a year or a few years. A Yellowstone-scale eruption could be far larger, but exactly how severe the climate effect would be is uncertain because it depends on chemistry, plume height, season, and atmospheric circulation. This is where the survival story gets less dramatic and more unsettling. Humans as a species almost certainly wouldn't go extinct from Yellowstone. The planet has seen huge eruptions before. People are adaptable. Food can be stored, moved, rationed, and grown in different places. But modern civilization is optimized for normal weather and just-in-time delivery. Many cities don't have months of food sitting around. Farms depend on growing seasons lining up. Livestock depend on clean forage and water. Global grain markets depend on multiple regions not failing at the same time. So the dangerous question becomes, what happens when a continental ash disaster and a climate shock hit food production together? That's the final boss of this scenario. Not lava, not one giant blast wave, food. And weirdly, this means your odds are shaped by boring choices made before the eruption. Building codes, emergency grain reserves, air filtration in hospitals, whether power crews have replacement insulators, whether communities know not to drive through ash clouds, whether people have water stored before the taps turn brown. Survival isn't only about heroic individuals, it's about whether the surrounding systems have slack. So, could you survive the Yellowstone Supervolcano eruption? If you're close to the park, probably not. If you're in the heavy ash corridor, maybe, but only if you get inside fast, protect your lungs, keep ash off your roof and out of your water, and resist the urge to drive through a gray blizzard made of glass. If you're far away, you likely survive the eruption, but you may still be living inside its consequences for months or years. The most important thing Yellowstone teaches isn't that the Earth has a secret doomsday button. It's that the scariest disasters don't always kill by being close. Sometimes they kill by making ordinary life stop working. The lights flicker, the water tastes wrong, the road disappears under powder, the shelves don't refill. And that changes the whole question. Could you survive Yellowstone? Maybe. But only if you understand that the volcano isn't just under the park. In a way, it's under every system we assume will keep working tomorrow. If you want the weird version of survival advice, it's this. Don't worry about outrunning lava across Nebraska. Worry about air, water, shelter, power, food, and the wind. The wind might decide whether Yellowstone is a distant headline or the gray dust on your windowsill.